Right, so question 2. We've got here double angle again for sine 2 theta. So we can replace it with the result that we know for sine 2 theta. So put a bracket there maybe. We know sine 2 theta is 2 sine theta cos theta. Close the bracket, equals then on this side 2 sine theta. So we can then times it by the 3, so we get 6 sine theta cos theta equals to 2 sine theta. Okay, we could even then see we've got a common factor of 2, so we could divide through by 2. So we get 3 sine theta cos theta equals to sine theta. Okay, like dividing through by 2. Now, tempting, isn't it now, just to divide by sine, because you've got sine on both sides, and then it would get rid of the sine. However, just like the first one, if you do that, you're going to lose certain results. Okay, you're not allowed to divide through by sine in this case, because sine could actually equal 0. Okay, and you're not allowed to divide by 0. So remember, when you get this, take it over to the other side. So 3 sine theta cos theta, take away sine theta, equals 0. You could then see we've got two terms, so we can factorize then the sine theta, because sine goes into both. So we're going to have then 3 cos theta minus 1 when you factorize. And then we've got an either or situation, because you've got the two things here, product of these two, the sine and the bracket is 0. So you could say either sine is 0 or 3 cos theta minus 1 is 0. Now if sine is 0, just like we had cos was 0 before, or if sine is equal to 1 or minus 1, just do a quick sketch because you can see the results straight away, right? So if you know the sine graph, it looks like this, yeah? Sine wave. So where is 0? It's here, here, and here. So let's just check the range of solutions, yeah, between 0 and 360. So we want all of these. So theta will be 0 there. That's 90, so that's 180, that's 270, and that's 360. So you've got 3 results there. Okay. For this one, I'm going to do a bit more work. So cos theta will equal to 1/3 when you rearrange that. To get theta then, you do cos to the minus 1 of a third. Okay. So we get, on my calculator, 70.5 degrees, okay, rounded to 1 decimal place. So we need to see what the other result is, so it's good to draw the cos graph now, okay. So remember, when you draw the cos graph, just like the sine graph, let's get sort of a decent scale here. Maybe we'll go 3 centimeters to represent 90. So we've got 1 here, and minus 1 at the bottom, so it's going in 90s. And you know the cos graph then, okay. If you're not sure, just put cos 0 in, cos 90, you get your values. By drawing a scale, of course, then it's easier to see the symmetry, even if your graph drawing isn't brilliant. So 70.5 degrees, well, and a third, isn't it? So a third is about here. Only a sketch at the end of the day, but a third is about there. You can see even with my sketch here, it looks pretty good, doesn't it? That is 70.5. The other angle is going to be here, okay? So, and there's a symmetry there, yeah? So that slope going down here is exactly the same as this slope going down here. So when you go down that slope, you're going across 70.5. It's exactly the same now. When you're going down this slope backwards, you're going backwards 70.5. So theta will, the two results to this will be 70.5, and because you're going back 70.5 from 360, you take it away. So 70.5 and 289.5 there, okay? And then you can couple that then with your other results. Therefore, theta is 0, 70.5, 180, 289.5, and 360.